Hey guys, I am back. Today we're going to talk about the thymus gland in relationship to viruses. It's the missing link. Let me explain. What is the thymus? It's different than the thyroid. Okay, the thyroid is located in the front part of the neck. It regulates your metabolism and many other things. The thymus is a little lower. It's right on top of the heart, right underneath your sternum right here. Okay, and when you're born, it's very, very large. And then when you get older, it actually shrinks. Okay, so the thymus is a lymph gland. It's a very important gland. I'm going to talk about what it does and what you can do to keep it really strong. The thymus has a very important primary function, and that is something called central tolerance. What does that mean, central tolerance? Tolerance is all about preventing a self-attack. Like in an autoimmune disease where your body is attacking itself, you have certain mechanisms in place that prevent that self-attack. Your body is supposed to differentiate between your own cell and a pathogen, because we don't want our own immune system to go rogue and destroy our own tissues. And this is a very interesting point, because in certain experiments, when they removed the thymus gland, all sorts of autoimmune diseases popped up. Okay, an autoimmune disease is very specific to a gland. So if you have an autoimmune condition to your thyroid, you have antibodies that are attacking itself. So the thymus has a very big importance in preventing this from occurring. Let's talk first about what is a T cell. And by the way, in the thymus, you have T cells and B cells. The T stands for thymus because it actually develops in the thyroid gland, whereas the B cells develop in the bone marrow. So there's three types of T cells, okay? And I'm going to try to keep this very, very, very simple. You have the killer T cells, which basically kill viral infected cells. So in other words, if that virus gets into that cell, this killer T cell will destroy the entire cell and the virus. And by the way, in order for this cell to develop, it needs iodine. So if you're deficient in iodine, what can happen is you might not have the full capacity of the killer cells. The killer T cells are basically like your special forces. Okay, now we have the helper T cell. The helper T cell works by coordinating the army. It doesn't necessarily do the killing, but it does tag viruses. So it will take spray paint and put a big X on the viruses or the pathogens that need to be taken care of. And those messages are sent to the killer T cells and other cells for them to do the dirty work. The helper T cells are the coordinator. They're in communication with the entire army. They do a lot of recruitment. So they will signal certain parts of your immune system and tell them to ramp up and get ready and send more troops because we need more help. Then you have something called the regulatory T cells. And this is very, very interesting. This cell keeps the immune system from overreacting. So here you are, you have this war going on between your immune system and this pathogen, and you have a lot of things flying around. You have inflammatory things, you have certain toxic chemicals that your army has to be able to kill off pathogens. Well, some of that leaks out and it actually irritates your tissue. You have certain what's called cytokines that are like weapons that your white blood cells use to kill viruses and bacteria and fungus and parasites. And when you get sick and you get a headache or the flu-like symptoms or a muscle ache or fatigue, what you're feeling are those cytokines or weapons from your white blood cell doing the destruction. Same thing with a fever. Your body is just trying to kill off something. The worst thing you can do is quickly try to suppress that with some medication. You want to let your body do its thing. You don't want to necessarily get rid of the fever too fast. And you want to kind of cope with some of these symptoms as long as you can, because your body is working. It's trying to fight off this infection. And realize also that the regulatory T cells need vitamin D, because if this cell is deficient in vitamin D, it cannot do its job. So this is where you get an overreaction of inflammation, and you could potentially get a situation where you have a cytokine storm, okay? Now, I don't know if you've been following the COVID-19 connection to the lung and how some people are developing what's called a cytokine storm. And that's when they're in intensive care in serious condition where they're on a ventilator or a respirator and they have this serious inflammatory reaction. Well, guess what? That is because this system or this cell is broken down and it can't calm down or suppress the reaction of your immune system trying to kill off this thing. So when you look at this cytokine storm where you have this inflammatory process, it's not that your immune system is overreacting, it's that part of your immune system is lost its function to suppress or balance out the other side. And it just so happens vitamin D can help this cell and it can also help suppress inflammation as well. And by the way, I think I already mentioned this, but the helper T cell also needs vitamin D to help coordinate the army. So you can see all of these cells work together. And by the way, this cell right here also has a job of preventing autoantibodies or autoimmune conditions. And so when you lose this function, you get autoimmune issues, you have allergies, you have all sorts of inflammatory conditions. And as a side note, vitamin D is one of the best anti-inflammatories. It's an immune modulator, so it actually suppresses an overreaction of the immune system. All right, now we get to what's called the B cells, okay? B cells basically make antibodies. Now, what are antibodies? You have 5 different categories of antibodies. Antibodies don't kill anything per se. What they do is they tag things, okay? They tag pathogens, viruses, and fungus, and parasites, so these other cells can do the dirty work and kill them. So the weakness of antibodies is that they can't actually see what's happening inside the cell. So once the virus gets in the cell, they can't really do anything. But that's why you have like cells like this that can tag the cell. And so this cell can destroy the whole thing. So here's the thing. Antibodies are very, very specific to certain pathogens. In other words, you may have an antibody to Epstein-Barr virus, for example, very, very specific. You might have an antibody to another pathogen. In fact, what's fascinating is the capacity of how many antibodies your body can actually develop. It can go up into the numbers so high, and I'm talking about 1,000,000 trillion antibodies. Your body has the capacity of making that many. So you can see the power of your immune system. You can have resistance or protection to pretty much anything. Now, some antibodies can also bind with the virus, okay, and just kind of leave it out to dry, but they don't necessarily kill it with any type of poisons. Like this cell right here releases certain, what's called cytokines that actually can poison or kill viruses. All right, so that kind of gives you a summary of what the thymus does. Realize that it's not just about vitamin D, it's also about zinc as well with the thymus, because if you're deficient in zinc, you get atrophy of your thymus gland. It shrinks, and so you're not going to have all these functions. So what's really, really important to support the thymus is zinc, vitamin D, iodine, keeping your stress low, and of course, avoiding sugar. If you haven't seen my video on supporting a healthy immune system, check it out. I put it right here.